in this example, we are going to go over squaring a square root. So if you square a square root, it's basically, let's see, the square root of x squared would equal the square root of x times the square root of x. Now, if we know from the previous example, I showed how the square root is really something to the power of 1/2. So that equals x to the 1/2, x to the 1/2. And then if we look from back before where we added exponents, or we added exponents with the same base, we know that that becomes x to the 1/2 plus 1/2, which equals x to the 1, or just x. So therefore, if you square a square root, the square root disappears and you're left with just the original number inside. Using that, the square root of 13x squared will just be 13x. Now a plus our x squared minus, and now the square root of x, which we just showed, will continue to be normal x, or single x, over the square root of 4, which is the square root of 2 times 2, which equals 13x plus root of x times x minus x over root of 2 squared, and see that 2 and that imaginary 2, which is going to be the same thing that happens here if you can see that already, which equals 13x plus x squared. I guess we didn't need to multiply it out, I just wanted to show you where it was coming from, minus x over 2 equals 13x plus x minus x over 2. And are we done here? Is this good to say final answer? No. Why? Because we can combine all of these x's. How? And why actually? Because that's an x to the 1, x to the 1, x to the 1. So 13x plus 1x equals 14x minus x over 2. How do we combine fractions? How do we add and subtract fractions? Look at the fraction video, you see that we need to have the same denominator. So I will need this to be over 2 over 2. So 14 times 2 is 28. 28x minus x over 2, which equals 27x over 2. And can we reduce either of these? No. So therefore your final answer is 27x over 2.